Good morning, students. Today I will discuss about the elastic collision in one dimension. In previous video, I have discussed about the type of collisions. So here I have made a diagram in which two bodies of masses m1 and m2, which are respectively moving with u1 and u2 velocities. If the value of u1 is greater than u2, then after a certain distance they will collide, and this is the picture during collision. After that their velocity changes. Let their velocity becomes v1 and v2 after collision. As we know that in elastic collision, the kinetic energy as well as the momentum of the system remains conserved. So applying the law of conservation of linear momentum, the momentum before collision, it will be m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2, or m1 u1 minus m1 v1 is equals to m2 v2 minus m2 u2, or we can write it as m1 u1 minus v1 is equals to m2 v2 minus u2, and this can be written as equation number 1. By applying the law of conservation of linear momentum, the total momentum of the system before collision will be equal to the total momentum of the system after collision. Because the kinetic energy is also conserved in elastic collision, so applying the law of conservation of kinetic energy, Ke before collision will be equal to Ke after collision. Before collision, the kinetic energy will be half m1 u1 square for this, and half m2 u2 square for the second body is equal to half m1 v1 square plus half m2 v2 square, or this half will cancel in each, so m1 u1 square minus m1 v1 square can be written as m2 v2 square minus m2 u2 square, or m1 u1 square minus v1 square is equals to m2 v2 square minus u2 square. Because we know that it is a square minus b square, so it can be written as m1 u1 minus v1 into u1 plus v1 is equals to m2 v2 minus u2 and v2 plus u2. This can be written as equation number 2. Now dividing equation number 2 by equation number 1, if we divide equation number 2 by equation number 1, then we will get m1 u1 minus v1 u1 plus v1 upon m1 u1 minus v1 is equals to m2 v2 minus u2 v2 plus u2 whole upon m2 v2 minus u2. This will cancel this, and u1 minus v1 will cancel u1 minus v1. Similarly here, so we will get u1 plus v1 is equals to u2 plus v2, or we can write it as u1 minus u2 is equals to v2 minus v1. This is the relative velocity of body A with respect to B, and this is the relative velocity of B with respect to A. Or we can say that the relative velocity of approach before collision is equal to relative velocity of separation after collision. It means that in elastic one-dimensional collision, the relative velocity of approach is equal to the relative velocity of separation after collision. Now, if we want to calculate the velocities of bodies after collision, we know that u1 minus u2 is equals to v2 minus v1, or from here we can calculate v2 as u1 minus u2 plus v1. This can be written as equation number 3. Now substituting these values in equation number 1, we will get m1 u1 minus v1 is equals to m2 u1 minus u2 plus v1 minus u2, or m1 u1 minus m1 v1 is equals to m2 u1 minus m2 u2 plus m2 v1 minus m2 u2, or m1 u1 minus m1 v1 is equals to m2 u1 minus 2m2 u2 plus m2 v1. Now it can be written as m1 plus m2 v1. If we take v1 as common and replacing it on the RHS, it is equal to m1 minus m2 u1 plus 2m2 u2, or v1 is equals to m1 minus m2 upon m1 plus m2 u1 plus 2m2 upon m1 plus m2 and u2. This can be written as equation number 4, or v1 is equals to m1 minus m2 u1 plus 2m2 u2 upon m1 plus m2. Now substituting this value of v1 in this equation, we can find v2 from equation number 4 and 3. On substituting the value of v1 in this equation, we will get v2. v2 is equals to u1 minus u2 plus m1 minus m2 u1 plus 2m2 u2 whole upon m1 plus m2. On solving it further, we will get v2 as m2 minus m1 u2 plus 2m1 u1 whole upon m1 plus m2, and this can be written as equation number 5. This is the velocity of second body after collision. Now here some special cases arises in which, suppose in first case, when the colliding bodies have equal mass, it means the value of m1 is equals to m2 and let it is equal to m. Then v1 is equals to m minus m. Substituting this value in this equation, we will get m minus m u1 plus 2m u2 upon m plus m, or 2m u2 upon 2m. This means it is equal to u2, or v1 is equals to u2. Similarly, the value of v2 will be m minus m u2 plus 2m u1 whole upon 2m, or 2m u1 upon 2m, which is equal to u1. This means v2 is equals to u1. This means velocity of body B after collision is equal to velocity of A before collision. It means when two bodies of equal masses suffer elastic collision, then their velocities are interchanged after collision. Now another case arises in which the second body B is at rest. If in second case, if the body B is at rest, it means in this case the value of u2 will be 0. So the value of v1 will be, the value of v1 is equals to m1 minus m2 u1 upon m1 plus m2, and the value of v2 will be equal to 2m1 u1 upon m1 plus m2. Now again there are some cases. In first case, if the bodies have same masses, m1 is equals to m2, let it is equal to m, and the second object is at rest, it is the first case of second situation, then the value of v1 will be, v1 is equals to m minus m upon 2m into u1. So the value of v1 will be 0 and the value of v2 will be 2m u1 upon m plus m, or it is equal to u1. This means if a body collide with another body of same mass at rest, then they interchange their velocities. Means it was the velocity of body B after collision, and it is the velocity of body A before collision. Now, in another case can arise here, if the mass m1 is very greater than m2 and u2 is again at rest, means the second object is at rest, then the value of v1 will be m1 u1 upon m1 and it is equal to u1. Similarly, we can calculate the value of v2, and the v2 equal to 2m1 u1 upon m1 means 2u1. It implies that when a heavy body collides with a light body at rest, then heavy body remains moving with same velocity. You can see here v1 is equals to u1, whereas the stationary light body begins to move with twice the velocity of heavy body. It is the velocity of second body after collision, and it becomes twice the velocity of heavy object. Here another case may also arise. If the value of m2 is very greater than m1 and u2 is 0, this means again the one object is at rest, then the value of v1 will be minus m2 u1 upon m2, or it is equal to minus u1. Similarly, the value of v2 will be 0. It means that when a light body collides with a heavy body at rest, because the value of u2 is 0, then it rebounds with its original velocity, whereas the heavy body practically remains at rest because it is the value of velocity after collision. So today we have discussed the elastic collision in one dimension